Another popular static analysis tool for Java is PMD, which stands for Programming Mistake Detector. Unlike SpotBugs or FindBugs, PMD analyzes the actual Java source code instead of compiled bytecode. Because it works directly on source code, it can detect issues related to code styling, readability, maintainability, and design that may not be visible after compilation. PMD helps the developers identify potential problems early in the development process, resulting in cleaner, more maintainable, and higher quality code. So here's a quick comparison. The major difference between PMD and SpotBug lies in what they analyze. SpotBug examines the compiled bytecode and focuses on identifying the potential runtime defects. PMD analyzes the source code itself and focuses more on coding standards, design quality, complexity, maintainability, and readability. For example, PMD can detect duplicate imports, inconsistent braces, overly complex methods, unused variables, and poor design decisions. PMD provides hundreds of predefined rules. So these rules cover common programming mistakes, coding standard design problems, maintainability concerns, and complexity measurements. For example, PMD can identify unused variables, unnecessary constructors, empty exception handlers, hard-coded values, duplicated code, and overly complex methods, and design and maintainability issues. Let's see what is cyclomatic complexity. So cyclomatic complexity measures the number of independent execution paths in a method. So it has a formula like complexity is defined by if statement and loops and case statements and catch blocks plus 1. Higher complexity means harder to test and maintain. One of PMD's most useful features is measuring cyclomatic complexity. Cyclomatic complexity represents the number of different paths that execution can take through a method. Each if statement, loop, switch case, or catch block increases the complexity. The higher the complexity score, the more difficult the method becomes to understand, test, debug, and maintain. As a best practice, developers should keep the complexity as low as possible by breaking the large methods into smaller ones. Consider this code. PMD increases the cyclomatic complexity for each decision point. So we have these decision points in this code as if n greater than 0 and if n is equals to 0. Then else is basically part of the same decision chain, so no extra increment will happen. So plus 1 makes the cyclomatic complexity to equals to 3. So as a rule, typical thresholds means cyclomatic complexity is less than equals to 10, then it is okay. If it is greater than 10, then warning, and if it is greater than 15, then high risk. So PMD doesn't care about variable assignments, return statements, code length. It only counts if else, loops, case and switch statements, catch blocks, and ternary operators. So simple takeaway is that cyclomatic complexity is the number of independent decision paths in a method, and PMD flags methods when these decisions become too many to safely test or maintain. PMD can be noisy. So PMD is noisy by default. When installed with default settings, PMD can generate a large number of warnings. For example, PMD may recommend adding a final keyword to every method parameter whenever possible. In large enterprise applications, this generates thousands of warnings and makes it very difficult to focus on truly important issues. Therefore, teams typically customize their PMD rule sets and disable rules that do not align with their coding standards. Now let's see how to install PMD in Eclipse like we have done for SpotBugs. PMD can be installed in Eclipse using either the Eclipse Marketplace or the update site. Open Eclipse and navigate to Help, then install new software, enter the PMD update site URL and proceed through the installation wizard. Alternatively, open the Eclipse Marketplace and search for PMD and install its plugin directly. For configuring PMD, after installation, PMD can be configured from Eclipse Preferences. Navigate to Windows, Preferences and select PMD. Here you can enable or disable specific rules, import custom rule set, configure reporting options and customize how violations are displayed. Once PMD installed and configured, right-click the project and select PMD check code. PMD scans the source file and highlights the violations directly in the editor. Violations can also be viewed through PMD Violations Overview window. Here is a demo program. So this is simple Java application that can be analyzed using PMD. Although the program executes successfully, PMD may identify issues such as naming convention violations because method names use inconsistent capitalization styles. After analysis completes, warning markers appears in the editor. Double-clicking a violation takes you directly to the problematic code and displays detail about the violated rule and recommended improvements. For example, method naming convention line number 8. So PMD says that method names should follow the Java naming conventions. So this is violation because Java methods should start with a lowercase letter and use camel case. So PMD detected that the method name call underscore method doesn't follow standard Java naming conventions. So Java methods should use camel case beginning with a lowercase letter, and following name conventions improves the readability and consistency across the projects. Method naming conventions reported at line number 14. So the method starts with uppercase C. PMD also identified the method because it starts with the uppercase letter. So Java recommends camel case method names such as call hello with small c, starting with small c. Third is formal pattern naming convention. PMD found that the parameter name input underscore parameter uses uppercase letters. So method parameters should follow camel case notations again. Then this print line at line number 11. PMD discourages direct console output. In enterprise applications, use logging frameworks and avoid debugging output in production code. For example, logger.info. So PMD flags the use of system.out.println because production applications should use logging frameworks rather than direct console output, and logging provides better monitoring and debugging capabilities. This is another instance of system.println. So PMD recommends replacing the console output with the logging mechanisms for better maintainability again. Then comment required at line number 8. So public methods should have documented comments. PMD requires public methods to be documented. Comments helps other developers to understand the purpose and usage of the code. Then line number 1, package case. So package names should be lowercase, and PMD reports a package case violation because packages names should be entirely lowercase according to Java standards. Then comment required at line number 5. The main method is public and lacks the documentation comment, so PMD flags it under the comment required rule. Then comment required at line number 3. Again, the PMD recommend documenting public classes using Java doc comments to improve the code maintainability and understanding. Method argument could be final at line number 9. PMD detected that a parameter is never reassigned. Marking it as final prevents accidental modification and makes the code safer. Then short class name at line number 3. The class name is considered too short by the configured PMD rule, and it reports that the class name main is too short. Descriptive class names helps the developers understand the purpose of the class more easily. Then unused local variables. So we should avoid unused local variables. PMD flags variables x and y because they are declared but never used. Unused variables clutter the code and may confuse future developers, so removing them improves the maintainability and readability. Unused private fields. So PMD detects private fields that are declared but never utilized. Unused fields consume memory and often indicate incomplete or unnecessary code. Hard-coded literals. So hard-coded values reduces the flexibility. If the business requirements change, developers must search the code and update the multiple locations. Constants should be used instead. Empty catch block. Empty catch blocks silently ignore exceptions. When errors occur, the developer receives no information, making debugging extremely difficult. PMD recommends logging or handling exceptions properly. Then unnecessary constructor. If a constructor performs no initialization, Java automatically provides a default constructor. Explicitly writing an empty constructor is unnecessary and adds extra code. Empty statement. An empty statement has no effect on execution. Although harmless, it creates confusion and may indicate a coding mistake. PMD flags such statement to provide code clarity. Now let's see the suppressed PMD warnings. So PMD warnings can be suppressed when the developers intentionally decide that the warning is not relevant. There are three common suppression approaches. First, using the add suppress warning with PMD suppress. So it's warnings with PMD. It suppresses all PMD warnings for a method. Second, a specific PMD rule can be suppressed by mentioning the rule name, such as PMD.inefficient string buffering. Third, individual lines can be excluded from analysis using the no PMD command. However, suppression can be used carefully. It is always better to fix genuine issues rather than hiding them. So PMD is a powerful static analysis tool that complements SpotBugs by focusing on source code quality rather than runtime defects. It helps the teams to enforce coding standards, reduce the complexity, improve the maintainability, and detects the design issues early in development. When properly configured and tuned, PMD becomes an essential part of modern Java quality assurance processes. Let's finish with a quick challenge. A Java program compiles successfully and produces the correct output. However, a static analysis tool reports that a method is becoming difficult to understand and test because it contains too many decision points. Which PMD feature is responsible for this warning? The correct answer is cyclomatic complexity. PMD measures the number of independent execution paths in a method. A method with many if statements, loops, or switch cases becomes harder to understand, test, and maintain even if it works correctly. A developer copies the same calculation logic into 5 different classes. The application works perfectly today, but future changes will require updating all 5 copies. Why would PMD flag this code? Correct answer is A. The PMD focuses on code quality and maintainability. Duplicate code increases the maintenance effort because every future change must be made in multiple places, increasing the chance of inconsistencies. A method contains only 3 lines of code, but its parameter is never modified after it is passed into the method. What improvement might PMD suggest? The correct answer is B. Since the parameter is never reassigned, PMD may recommend declaring it as final. This prevents accidental modification and makes the code easier to reason about. The company text rate is used in more than 50 different classes. Each class contains the value 15 written directly into the code. What would PMD most likely recommend? The correct answer is B. PMD discourages hard-coded literals because they reduce the flexibility. Using a named constant makes future changes easier and improves the maintainability. 2 Java methods produce exactly the same correct output. One method has 3 decision points while the other has 18 decision points. Which method is PMD more likely to flag and why? PMD is more likely to flag the second method because its cyclomatic complexity is much higher. High complexity doesn't necessarily means that the code is incorrect, but it makes the method harder to understand or test, debug, or maintain.